Hello, ladies and gentlemen. Welcome back for day 2 of the first part of our second unit. We're going to be discussing dot plots, histograms, and describing shape today. Now, in day 1, we talked about what data analysis is, how we gather data. Now, once the data sets necessary to answer our questions of interest have been gathered, and we know whether they are quantitative or qualitative, in other words, categorical, we can complete a surface exploration called exploratory analysis to determine if there's anything interesting within each data set individually and or comparatively that would warrant further study. To organize our answers, we go through what we call a 4-step process. We first state, all right, what's the question that you're trying to answer? We come up with a plan. How will you go about answering the question? What statistical techniques does this problem call for? We actually do our plan, so we make the graphs and we carry out any needed calculations. And then we write a conclusion. We give our practical conclusion in the setting of the real-world problem, trying to answer our original question. Now, to model the methods that we use to explore our data distributions, I'm going to use census data gathered from my Fall 2021 and Fall 2017 AP Statistics classes, respectively, to answer the question, are my seniors getting taller in comparison to my own height of 65 inches? I'm about 5 foot 5 inches. All right, last year, I noticed that I needed to look up while talking to my seniors more often than in past years, or at least it felt like that. All right, so we want to figure out, is there any evidence to back up my observations? All right, let's find out. To explore this problem, I need to create graphs to visualize the data and calculate numerical summaries appropriate to the shapes of the distributions. I'll also need to calculate z-scores and or percentiles to quantify how my height ranks compared to the heights of students in each year respectively. All right, so this is the data that I gathered. This is real data from my students last year and then my students from several years ago. I always give a survey at the start of the school year, and one of the questions that they answer is how tall they are. All right. I'm going to begin my exploratory analysis by making 2 graphs. I'm going to make a dot plot and then a histogram to visualize the distribution of heights reported by my Fall 2021 AP Statistics classes. For these initial lessons, I'm going to focus my instruction just on the Fall 2021 data. I've already completed the same steps to analyze the Fall 2017 data off screen, and it's already included in the packet. All right, let's go ahead and flip pages. And we're going to start off with how to make a dot plot. All right, so a dot plot is one of the simplest types of graphs to construct and to interpret because each data value is shown as a dot above its location on the number line. All right, the number of dots in each location shows how frequently each value appears in the distribution. So let's kind of explore how to make this dot plot using this data. All right, I've already created a number line for us. And as you can see down below, I've created the dot plot for the Fall 2017 AP Statistics student heights. Right. It's always very important to evenly scale your number line as well as to title your number line. All right, the height in inches is my title. All right, so let's go through and start creating this. All right, 63 is going to be between 62 and 64, so I'm going to create a dot right in the middle of those. That represents 63. 65 is going to be between 64 and 66. I have another 63. That means I need to put another dot above the previous dot for 63 because I have 2 of those students. That's why I need 2 of those points. Each point represents an individual student height. All right, since some students may have the same height, as I see the same height again, I'm going to put another dot equally spaced moving up. All right, 65 again, I want to make sure that my second dot is even with the second dot from 63. 64 is going to go right above the 64. I want it in line with these first dots. 65, I need a third dot here, evenly spaced. 61, right in the middle of 60 and 62. I actually need to move that up a little bit so that's even with my original dots. There we go. 59, right between 58 and 60. 62 is going to be between my 61, 63, 68, 69, 70, 68. Notice that I made sure that that second dot for 68 is even with these others. 64, again, making sure that's even so that everything that has at least 2 dots is at the same height. 70, 66, 67, 62, 69, 72, 62. Oop, that's a little low. Let me move that up just a little bit. Sorry, my pencil's leaving a few streaks here. 67, 60, 66, 63, 67, 66, 60, 61, 71, 63, 67, 62, and 64. All right, and now we have our completed dot plot. Now, even though it almost looks like we have two peaks, the heights of the numbers from 62 to about 67 are so close in height, we wouldn't actually call that a distribution with two peaks. We would just call it still single peaked. We can put in a curve over the distribution, and you can see that I could almost fold this in half and have it kind of fold onto itself. Same sort of thing over here. If I draw a curve over this distribution, now this one has a slight bump, but still it's so close in height to the others, I wouldn't necessarily call it a second peak. It needs to be rather extreme, like these peaks, in order for it to be considered a second peak. All right, now, what do we notice about these two graphs? I'm going to take a brief moment, and you're going to see a question pop up if you're doing this on Edpuzzle, so that you can answer this question. What do you notice about these two graphs? Now, what I notice is that one of the graphs seems to be kind of single peaked, fairly even on either side of the peak. And I noticed that this graph here is kind of, most of the points are on the lower section, and then I have just kind of a few points stretching off into the distance. All right, so they seem to have different shapes. All right, so the two distributions seem to have different shapes. And as we complete this lesson, you're going to learn how to actually name those shapes. All right? Let's take a look at the histograms and see if it shows us anything additional, or lets us see the shape any easier. All right, now, to make a histogram, since quantitative variables often take many values, a graph of the distribution is clearer if nearby values are grouped together. All right, this is why the most common graph of a distribution of one quantitative variable is a histogram. All right, now steps for making a histogram. All right, divide the range of the data into classes, we also call them bins, of equal width. All right, you need a minimum of 5 classes. Now, if you look at the histogram I already have created over here using the fall 2017 data, I created bars of width 2. All right, those are my classes or my bins. All right, so I have bars of width 2, and I have 1, 2, 3, 4, 5, 6, 7, 8 bars, so I have at least 5. All right, you need at least 5 to be able to see the shape of the distribution. All right, now we need to find the count, in other words, the frequency, so how often the numbers appear, or the percent, which is the relative frequency of individuals in each class. Now, creating a frequency and relative frequency table helps to keep us organized so that we can avoid redoing the same work multiple times. Using a dot plot like the one that we made earlier also helps organize the data. All right, so I'm going to be kind of referring back to my dot plot as I go through this. All right, you need to label and scale your axes and draw the histogram. Label the horizontal axis with the variable whose distribution you are displaying. The vertical axis contains a scale of counts or percents. All right, each bar represents a class. The base of the bar covers the class, and the bar height is the class frequency or relative frequency, in other words, percent. I draw the bars with no horizontal space between them unless one of those classes is empty so that the bar height is, has a height of 0. All right, so let's explore how to follow these directions and actually make a histogram using the height data from my 2021 AP Statistics classes. All right, so on the right down below here, you can see the histogram for the distribution of height in inches from my fall 2017 AP Statistics classes. All right, so over here, we're gonna do the same thing for fall 2021, and I'm going to separate my packet a little bit so that I can actually see these side by side. I'm gonna use a sticky note here to write up my different classes. So the different ranges of heights. First, I'm going to look at my frequency, and then I'm going to have to calculate my percent. And so the first bar over here started at 58 and went to 60. I'm going to do that same thing. So 58 to less than 60. The important thing to know with histograms is that the beginning of a bar, the number that starts the bar, is actually included in the count. The number a bar ends on actually starts the count for the next bar, so this 60 is not included. This would include 58 all the way up to 59.9 repeating, but as soon as you went to 60.0, you're going to be in this next bar. The same thing with 62 is going to be in the third bar, 64 will be in the fourth, and so on. So we write this down as 58 to less than 60 to represent the fact that 60 actually starts our next class. I'm just going to go ahead and write up the beginnings of my table to save us a little bit of time. To less than 70, 70 to less than 72, and because I had at least one student at 72, I do need to have 72 to less than 74. Now keep in mind, just because you have a bar that extends to a certain number doesn't necessarily mean that that last number will be found in the data set. Let me fix my Q up here so that it actually looks a little bit more like a Q and less like, I don't know, some weird shape. All right, so the frequency. So 58 to 60, this is where I'm going to use my dot plot to help me with this. All right, so I'm gonna move back over here and I'm actually just going to count up the numbers that fall within these ranges. So 58 to less than 60 would include the 59 here, so I just had 1. 60 to 62, I'm gonna include the 60 and the 61, so that would be 4. 62 to 64, so that'll be my 62 and 63. I have 4 here and 4 here, that's a total of 8. 64 to 66, remember 66 goes in the next one. So I need to count 64 and 65. It looks like 6 total dots there. 66 to 68, again, excluding that 68 because it starts the next bar. So just the 66 and 67, I have 3 and then 4, which gives me a total of 7. 68 to 70, so the 68 and 69, that gives me 4 total dots. 70 to 72, that gives me 3. And 72 onwards gives me just 1. Now, because I later want to compare my two histograms, I'm going to calculate the percents instead of just the frequency. I had a different number of students in my AP Statistics classes in 2021 compared to 2017. I can't compare the counts directly. I need to actually standardize it by turning it into a percent so that all of my bars are basically out of 100. And when you're just looking at a single histogram, you're not comparing it to any other data, then you can do the frequency histogram. You need a relative frequency histogram, in other words, percents, when you want to do a comparison between two data sets that have a different total number of data points. And so from here, I'm actually going to use a highlighter to highlight these bars. So I need to have from 58 to 60 is going to be just 1. So 58 to 60 goes like that. And then 60 to 62, whoop, and I already made a mistake. And it's okay if you make a mistake. Realize it, correct it, and adjust it here. My percent is gonna be higher than my single count, so it'll be fine. All right, we'll fix that height here in a minute. Remember, teachers make those kinds of mistakes too. I have a total of 34 students last year in my AP Stats classes. So if I take 1 divided by 34, that gives me 0.029, et cetera, multiply by 100 to turn it back into a percent. I have about 3%. 4 divided by 34 times 100 gives me about 12%. 8 divided by 34 times 100 gives me about 24%. Now, because I'm rounding these percents, I might end up with a total percent that's higher than 100, but that's okay. We know that it'll happen just because I was rounding. 6 divided by 34 gives me about 18%. 7 divided by 34, about 21%. Now 4 divided by 34 I did previously, that was 12%. 3 divided by 34 times 100 gives me about 9%. And then the 1 was about 3%. All right, so the percents I actually want to use the height of. So I need to fix this so that my height actually goes up to 3. That means that I need to actually have my bar like this. See how easy that was to fix? Next, I need 12%. So I'm going to have this next bar going up to the 12. All right, next one's up to 24%. Next is 18. $21. $12. 9. Oop. Well, and sometimes that happens. If you have that happen like I just did, yeah, it's okay. I am going to use a little whiteout thing and just kind of, clean it up a little bit. All right, anytime I make that mistake on my own work, or I did when I was in high school, I cleaned it up and then I went back over it with a black pen. Just, put the grid lines back in. There you go. It's almost as though it never happened. So don't stress if you make a mistake. Just fix it, move on. It's not that deep. All right. And if it makes it easier, you can even emphasize, the outlines of these bars. To remind yourself of where one begins and the other ends. You don't have to, but if it makes it easier for you to visualize this, then do so. Right? And you can probably see what I meant by this is essentially a single mound shape. Right? Kind of similar to what we ended up with here. Right. Now, are there any key features that are easier to compare when using the histograms instead of the box plots? And I want you to go ahead and try to answer this question. Right. So any key features that are easier to compare when using histograms instead of dot plots? Well, I'd say that the shape might be a little bit easier. So the shape and the peaks. So where it reaches its greatest height, are a bit easier. Right. Now let's actually talk about these shapes. In the fall 2021 distribution, you can see that the majority of the data is clustered in the middle and it tapers off pretty evenly on either side. In the fall 2017 data, you can see that the heights are mostly clustered in the lower end, and then there are a few taller heights that kind of spread out to the right. Now, what is this called? All right, let's actually discuss how to describe a quantitative distribution. All right, now this is just part one. We're going to keep updating these details as we go through this unit. All right, so when examining the distribution of a quantitative variable, you need to look for the overall pattern and for any striking departures from that pattern in the graph or graphs. We can describe the overall pattern of a distribution by its shape, center, and spread. The center of the distribution can be described by identifying its mean, median, and/or mode. The spread tells us how variable the data is. One way to describe the spread is by calculating the range, which is the maximum minus the minimum. Finally, in addition to describing where the majority of the data points are clustered, we should also identify any unusual features or outliers. All right, these would be individuals that fall outside of the overall pattern. All right, now below you're going to find some important definitions to help you verbalize what you see in your graphs. All right, so for the shape, when describing a distribution's shape, concentrate on the main features. Look for major peaks, not minor ups and downs. Look for clusters of values and obvious gaps. Look for any potential outliers, not just for the smallest and largest observations. And look for rough symmetry or clear skewness. All right. A distribution is roughly symmetric if the right and left sides of the graph are approximately mirror images of each other, like over here. If I draw a line through the two, I could actually fold this onto itself and it would be a mirror image. So the data is split evenly. If you folded it, it would be the same. Now, distribution is considered skewed to the right. If the tail would be on the right, that means that more data is on the left and you have it kind of stretching out and being distorted on the right. Skewed left is the opposite. The tail is on the left, so the majority of the data is on the right, and then it's being distorted and stretched out on the left side. When you look back at the dot plot for my 2017 data versus the dot plot for my 2021 data, my students in 2021 had a roughly symmetric distribution. My students in 2017 had a right-skewed distribution of heights. Now, there is an important note that you need to keep in mind. Although the mode is a measure of central tendency, it's more frequently identified when stating how many peaks a distribution has as part of the shape description. All right, single peak distributions are referred to as unimodal because they have a single value that appears the most, uni meaning one, modal meaning mode, so one mode. A distribution that has two clear peaks is referred to as bimodal, bi meaning two, modal meaning modes. And distributions with three or more peaks are identified as multimodal. And again, they need to be major peaks, not minor ups and downs. All right, we're going to discuss other measures of central tendency and spread in the next lesson when we calculate the numerical summaries that quantify the key features of our graphs. All right, your assignment. So during class tomorrow, we're going to need you to please create a dot plot and a relative frequency histogram, so a histogram using percents, for each distribution that you gathered from your survey questions yesterday. Check your work with your group members and discuss any similarities and differences you notice between your graphs. Describe the shape of each graph so that you know how to move forward when you're calculating your summary statistics. All right? We'll see you in class.